Hello all, this is just a quick video about using diagrams to demonstrate the truth of Venn diagram statements. Um, so these are Venn diagrams as you've seen before. This has two subsets. This universe has three subsets. And what we're going to do is we're just going to explore how you can use the Venn diagram as a visual. So when you draw a Venn diagram, often you will be asked to shade the area that represents the set that you are talking about. So for example, if we are talking about set A is everything that is part of A, and that includes the stuff that also is part of B. But if I'm just asking for set A, we would shade in the circle that is A. For set B, we would do the same thing, but instead of the circle A, we would get the whole circle of B. And again, it will include the parts of B that are also A here, but this circle represents the set of B. If we were trying to represent the set of A intersection B, the first thing you have to make sure that you understand is what this notation means. Remember that this symbol stands for intersection, and an intersection is asking for what values do they share. So in this case, the values that they share are located in this overlapping area, so we would only shade in that part. You'll hear me, I tend to call that the almond because it kind of looks like an almond. So back over here for this first one at set A, that was the whole circle. Set B was a whole circle. The intersection of A and B is just the almond in the middle. Now, for this next example, A intersection B not, what that means is that we would actually sort of work like order of operations. So we would figure out what area is represented by what's in the parentheses. So working with the parentheses first, it would be the intersection of A and B, which we already established in the previous example. Then the not, that's the negation. So that would be everything that is not A and B. So if A and B is the almond, then everything that is not A and B is actually going to be the whole thing except that sliver in the middle. So everything would get shaded in. Everything that's not A and B is all of the places that represent that is either A or B or neither of those. So we would shade everything except for that center part. If we look at this next example, A union B not, so that we want the complement of A union B. Well, A union B represents the area where everything, where it's all parts A and everything that's B. So all of the A circle in addition to all of the B circles. So that would be A union B. But we want the opposite of that. So we want the complement of that. Well, what's shaded in is the two circles. So now if we want the complement, we would actually just shade in outside of the circles. So everything that is outside of the circles is what actually gets shaded in, like that. All right. So these are just ways to represent what we're talking about in a Venn diagram. If we go to the sets of triples, the same principles follow. It's just that we now have three sets. So for set A, we would still just be circling everything, shading in everything that's inside A. So it's just that A circle. If we wanted set C, it would just be everything that was inside the circle of C. If we want everything that's not A, well, take a look at this first example, and everything that's not A in this diagram would be all of the stuff that's white. So the stuff that's pink that's A, the stuff that is pink is A. The stuff that is white is not A. So in our example, we would shade in everything that wasn't in the A circle, like so, including that little smidge up top. In this last example, we have A union B union C. So that means we want all of the stuff that is either A or B or C. So everything that's A in conjunction with everything that's B in conjunction with everything that's C. So for these, we end up just shading in the circles. Okay, hopefully those are enough examples for you to kind of work on your own. I have given you an assignment. Thanks.